All right. Uh, Now we got bunch of ideas about all these concepts, the class, objects, messages, different kinds of relationships, uh, but how to use them to solve your problem in the real world. It's so important for all of us. Could you write code directly once you know your problem? You can't because you have no idea about it. You must think about this problem. Think about its architecture or the models inside it. And then you can write code in program language. So in Java, it's a really important way to think about using the object-oriented technology. This is correct way to solve your problem. So I will give you example, a real example to demonstrate how to use these concepts, how to thinking, make the thinking works for your problem, and you can follow these steps in the future if you want to solve your own problem. Okay, now we have example. This example is really simple. It's a Kick Me application. Switch to this. Oh, it's NetBeans. Okay. Well, now we get into NetBeans. This is what my project name, my project folder, and then this is my code, and just run it. It's Click Me and launch this application. Well, it's a desktop application with graphics user interface, so it's a window. But inside the window, nothing in it. I can use a mouse to go there and go there and go around inside the window. But if I click my mouse, I have a mouse. The mouse has two buttons. If I click the mouse button, well, we'll see the red dot appear at the location where I click my mouse. And if we move the mouse to another location, another place, and click the mouse again, well, this red dot is displayed here. And we move there, click the button, move there, move there, move there. Well, the click button is follow me clicked around inside the window. Well, this is the Click Me application. This is what this function of the application. Okay, now if you want to build the application like this, how to think about how to make your own design. Well, it's very important. And at the very beginning of the chapter, we are talking about uh, the mapping method. It's a correct way to solve your problem. That is in the problem domain and mapping all the items and relationships inside the problem domain to the object domain, to the objects and this relationship between the objects inside the object domain, and use a mapping method. So it's very important for us if you want to solve your problem in the real world the very first thing, the very important steps that you should think about in the object-oriented way, that is inside your problem, what is the items inside it, and what is the relationship between these items. And then you can do the mapping operation to get the objects, to design the objects and this relationship in your object domain. And then you can code, you can do coding for it. So back to our application, the click me. Now I have a window. Now window must be the object. And we have a now have spot. A spot in this system, we have a coordinating system where the position of the axis and the y-axis. So we got x and y. It's a location of the spot. So we should have the object. It's a spot. Now we have two objects. One is our application, our window. It must be an object. And then we have spot, another object. But is any more objects should exist in our system? Yes, because we can see these spots inside the window. So we must have a tool or an agent or a model that is function is to make these spots available to us, make us can see it in red color. So we must have objects that help us to display these spots on the screen. So we have third objects that help us to display the spots in red color and a tiny circle filled with red color. The third object. And it's not enough. We must have another object because the position of the spot, where it come from? It comes from the mouse. As we know, we use the mouse, we move around inside the window. How we get this mouse? It's from the hardware. And through the option system, we get the position. But how to get the position in JVM? So we must have a special object. The object's function is to help us to get the location, get the position of the mouse at any time when we click the mouse. So there's a fourth object that should exist in our system. So we have at least four objects in our system: the window object, the spot object, the geometric spot object, and the objects that help us to display the spot, and an object help us to get the mouse position. So I have four objects inside our application. This is very important steps. That is, now we know we should have four different objects inside our system. The next step, we think about the relationship between these objects. Which kind of relationship we should use. Now we know we have different kinds of relationship. Before, that is the inheritance, for example, and dependency, or the aggregation, or the composition. Which kind of relationship is suitable for us to describe one of these relationships between these four objects? So we must think about it. To think about these relationships and use a suitable and choose a suitable relationships we have named and use them to describe the relationship between our objects. So that is the second step. So we're thinking and finally find the solution and we use the UML to describe, to draw a picture, to draw a diagram for our system. Okay. And here is a diagram. Now we have these are the four objects here. The first object is my window. We name this kick me. It's our window. Well, it's my window in my desktop. The next object is a spot, the geometric spot, and its position, X and Y, and decide where the spot is inside the window. And with third object that help us to display the spot on the screen. And this object will limit graphics. Actually, it's not an object created by us. It's object we use as API because the Java platform gave us this object. We can use it directly. It can help us display stuffs on the screen. Okay. And this graphics, this object, the third object, can help us display spots in red color. So the red color inside the Java is the object. So it's a red color object. There's a third object. And the fourth object, its object can get the mouse position when I click the mouse. So name it as my mouse listener. Well, there's a fourth object. Now we have four objects. My window, the click me, and a spot, and graphics, and my mouse listener. We have four objects, and now we consider their relationship. We think about how these objects connect with each other and collaborate with each other. Well, look at this object and me, click me, and spot. A spot, when it comes out after we launch my window, after we have this click me object. So the spot must be the individuals, and click me should be the entirety. So the relationship between the click me and spot should be aggregation or composition. Which kind of relationship is suitable? The aggregation or the composition? Well, we must make a decision. Well, we must find there's a condition, that is the spot object is created by click me. If there's no click me object, there's no spot object. So the click me, my window object, must be in charge of the life cycle of the spot. So the relationship between the click me and spot must be the composition, not the aggregation. So we use this symbol, the field, numbers, and the arrow, put them together and describe this relationship between them. We have one click me object, and we have maybe one, maybe two, maybe not of a bunch of spots. We use N to stand for a lot of spots. Yeah, and in the same way, between the click me and graphics, between the click me and the mouse listener, must be the same relationship. They are all the composition. So we have click me, one click me, one mouse listener, one click me, one graphics. We use number to mark this on this symbol. So this is arrow. So this is arrow. Okay. Now we have this composition relationship, but that's not enough. Now we think this graphics. This graphics is an object provided by the API, the Java platform. Each object can use to display stuffs on the screen. And how to use it? The click me and graphics. So the graphics, I remember I've give you example about the dependency of relationship, that person to buy a car, person buy food, between the person and car and food, there is a relationship with them, the dependency. It's an operation. Here the same. The click me, use the graphics, use as object to pen something, to display something on the screen. So we use this operation as pen. So this graphics must add a parameter to pass into the operation. To use the click me in pen operation to do the pen job on the screen, draw the point, draw the spot with red color. So between the click me and the graphics, not only the composition relationship, they have another relationship between them. There is dependency. So we email, we use this arrow to describe this kind of relationship. Okay, so you must understand that in the object world, between two objects, they may have more than one relationship. As here, as example, the click me and graphics. Between them, we have two different kind of relationship. One is composition, another one is dependency. Okay, and between the graphics and the color, it's a dependency. The graphics use the red uses object to set corner. Use this operation to set the corner for our tiny circle filled with that corner inside the screen. So it's a dependency relationship. And between my mouse listener and click me, as we know, there's a composition relationship. And my mouse listener. The mouse listener is an object can get mouse from the option system. And the very important task for this object is information that it should get. It should get the position, the actual position of the mouse. And the actual position of mouse is stored inside the object named as mouse event. So we have a mouse event as object. If we got this object, we get the position of the mouse. The mouse event object is provided by the API, by the platform. It's the same as the graphics. So the mouse listener must use this mouse event object to get the position of the mouse. Between them, the relationship, the mouse listener use the mouse event to do some kind of operations to the mouse event. So the relationship between them is the same as the graphics and the counter. So it's dependency. So we use dependency to describe the mouse listener and the mouse event. The mouse listener used a mouse event to get the position, to get the position of this mouse. Okay, get for example, get X, Y, get the position of the mouse. Well, the mouse listener. Where does the mouse listener come from? We create our own mouse listener in our application. But if you want to use the mouse function, how you should do? We have lots of applications in the JVM. They all need the mouse position, need information from the mouse, from the operating system. If we want to do this, how they should do? That means all these applications want to get the same function, get the same information from the system, from the JVM. So the suitable way for solve this problem is use interface. So inside our system, our platform to provide us a lot of different interfaces to solve this kind of problems. Here's a mouse listener as an interface. And if my mouse listener to implement this interface, it can use the mouse. It can get the mouse information. So between my mouse listener and the mouse listener interface provided by the system, by platform, the relationship between them, it's the interface inheritance. So use this arrow to display the interface inheritance relationship between them. And back to ClickMe. ClickMe is a window. Wow. How to create a window? We cannot do it by myself, all by myself. It is a possible task. So it's the same. In the API, the platform provide us a class named as JFrame. This is a class that helps us to create window our system. So simply, we make a subclass from JFrame. The JFrame superclass derived a subclass, and the subclass can make its own window. So ClickMe is the same. We inherit our superclass JFrame. As a subclass, we can create our own window, our desktop. So between the ClickMe and the JFrame, it's inheritance relationship. We use this symbol to describe them. Now we understand the relationship between all these objects, and we know all the objects and all these relationships, all the relationships. So we have got the architecture of our system. We have made the object domain a variable. So next step, the task is really easy, and use the Java programming language. We make the code for these objects, for the relationships. We use code write to present, to implement these objects and their relationship. Well, let us see some of the code. Maybe lots of statements or the symbols now, because we have not get into the next chapter. The next chapter is about the language features. In the third chapter, uh, we know more about this language features. At this time, we only understand the concepts is enough. Now we have the class. We define class. Its name is spot with class, and inside the class, inside the brackets, it's a class body, and we define as variables the position of the spot, x and y, and the size. The size is the tiny circle, the readers. So we define a size with three variables inside the spot class. That's the spot class, and we define a class named kickme. It's our main class, and this kickme, as we know, between kickme and JFrame, we have inheritance relationship. So we use the keywords extend to describe this relationship. Now JFrame is superclass, kickme is a subclass. Okay. And inside this class body of the kickme, because we have this individual, the spot, the mouse listener, the graphics, things like that. So inside class body, we should define the reference variable for them. For example, the graphics, my mouse listener, and spot. And the very important things, because this relationship is composition, that means inside this code we have these statements to create this object for the spot, for this mouse listener or graphics. So we have this statement to create object for them. For example, now, we have this these statements. Get graphics. We use a statement to create a graphics object inside our kickme as an individual of our system. And now another object, for example, the spot. Where the spot? Where the spot? Oh, here we go. Well, this spot is here. We use the statements. Well, it's a new spot with a new keyword. We'll talk about in detail in the fourth chapter with new keyword to create object based the class based the blueprint. We create a spot object, and the mouse listener. Where's the mouse listener? Well, come back, mouse listener. Well, just here. Well, mouse listener, we use new, the same keyword new, and create the mouse listener object here. So in the code, we use the code to implement the composition relationship described in UML. Well, and come back, and now we see this dependency of the relationship, how to describe them in our Java code. For example, the kickme will use graphics to draw the circle on the screen, to read dot on the screen, use pen method. So in the code, let me find where there's a pen method. Well, just pen method. Well, it's a pen method. You may notice the pen method is the method inside kickme class. And the pen method, the graphics, well, it's inside the parentheses. It's a parameter. So it's a target of this pen. So kickme, our window, will use pen method, and I put this graphics, this object into the pen method, and so we can use this graphics object to draw the dot, the red dot on the screen. So here we have this object, so we can use the fill oval. This is method to draw a circle and filled with a corner. We get a set corner. We use this method to get corner object, and then we use this corner to draw the circle on the screen, the red dot on the screen, so you can see it. So this is the dependency, how we implement it using Java code. Is here. At the same, uh, if we want to get to mouse position, we use the mouse event. Back to this diagram, let's see my mouse listener. We use the mouse event to dependency relationship between them to get the mouse position, and then we can see the code here. Well, here we go. Well, there's we spot uh, spot position. It's a variable, and we the EVT stands for the mouse event object. Well, so my mouse listener, we want to get the position of the mouse. We use the mouse press method. The mouse press method, it means when we click my mouse, we press my mouse, and the mouse event as object to pass into this mouse press method as the parameter. And between my mouse listener and the mouse event, they have connection, they have dependency. The mouse listener to do operation, the mouse press operation, and use mouse event as a target. So when we do the operation, we can get the mouse event object, and then we can use the get x and get y, use this method to get this actual position of this spot. Well, this is how this code works. And the interface, my mouse listener implements an interface named mouse listener. Here's the code. And the mouse listener, we can see now it is my mouse listener, and this is mouse listener is the interface name. And if we want to implement a interface inside using in Java programming language, a keyword named as implement used to describe this relationship. And my mouse listener will implement an interface named as mouse listener. Once we implement the mouse listener, and we can use the mouse function, we can get the position from the system. And the user position, we use it on a screen. We draw a tiny circle filled with red color, so you can see it. So back to our application. Now we understand how the application works. When we click the mouse listener on this object can get mouse position from the mouse event object, which provided by the Java platform. So we get x, y, the current position of the spot, the geometric spot. And then how to display it? We use the graphic object to help us to display it on a screen. Use red color. It's a tiny circle filled with the color. We use graphics. And when we move the mouse to next place and press it again, so we get a new position from the mouse event, we get a new x and y, and in the x and y in the position, we use the graphic object again to display this spot with the color. And then each position will create a new spot object and display it on a screen, and then the next, and then next, and then next. So our application me works. Oh. So it works based on this collaboration between all these objects. Window, me, and spot, and mouse listener, and the graphics. They work together and build our application and made it works. It's what we should understand. And in the future, this is the correct way to, to create your own application. So the very first step is not to write code directly. It's you must sit down and think about your application, think about your problem, think about they should be objects inside the application. Which kind of object should we define, and which features should we get, and we should remove which kind of features that necessary for our problem. We should think about it, and then think about the relationships between these objects and use this relationship I have learned in this chapter. For example, the inheritance or the interface or the aggregation or the composition. Yeah, use them, and then you get a diagram. You use UML, you can draw the diagram, and in the diagram you get architecture of your system, and the next step you get into coding world. That's the correct way to build your own system to solve your problem in the real world.